Right. I'm going to use a notepad to finish the basic configuration. And then when I get into IPsec, then I'll do it on the command line. Enable config T interface loopback 0, IP address 10.1.0.1, 255.25250, interface G3/0, bring it up, IP address 13.13.13.1, 255.255.255.0. And I'm going to write a static route. I do not want to write a routing protocol. The reason why is I don't want too much traffic. I want to sniff the packet with Wireshark here and show you only those ESP packets, only those IPsec packets. So if you have OSPF, then okay, I can have OSPF and do filtration. Okay, let me filter. So I'll do like this: IP OSPF 1 area 0. I'm running OSPF only on the WAN interface, not on the LAN interface. Next.
Later, if you send me also the notepads.
But I'll be changing the numbers. I'll reuse the same notepad for the other routers. You understand what I'm saying? I'll go and do the alteration.
Yeah, I will make notes. That's why.
Okay. Or you can do one thing. You can copy from the. You can copy from this video. Fine. You want in a notepad, right? I'll put it for you in another notepad. This is router 1 configuration for you. Now for router 2, I'm going to use the same notepad, you see. 10.2.0.1. This is going to be 32. 2. And again, we are running OSPF on the WAN side. Copy. This is for you. And now I'm going to put this for the console. Now one middle router is left. On the middle router, which is acting like an internet for us. The configuration is on the loopback. I don't want any loopbacks here, but I do have another interface G4/0 whose IP address is 32.32.32.3, and on the G3/0 the IP address is 13.13.13.3. And I must run OSPF on both interface to form adjacency. Let's paste it. And when I paste this configuration, I'll be able to reach R1 from R2 and vice versa. All right, I'm putting all these configurations for you in the chat window. All right. Now we're going to do phase 1 configuration, crypto, ISAKMP. We are not doing IKE version 2 now, we are doing IKE version 1. So the command will not be IKE proposal. IKE version 2 proposal is only for version 2. For version 1, IKE, this is crypto ISAKMP policy. and we give any number, and this number is locally significant. It doesn't need to match with the remote site. Next, for encryption of the password, the key, you got three protocols. You can use any one of this, but if you are using, for example, 3 days, you must configure the same on the other side in order to have successful association. So, what protocol you want me to use for encryption? Sorry, I'm not hearing from you. What protocol you want me to use for encryption?
Um, IS,
What?
AS.
AES. Okay. AES. Advanced Encryption Standard. Okay. Now,
It's more secure, right?
yeah, more secure than the other two. For hashing, what protocol you want me to use? MD5 or SHA, which one?
SHA
Okay.
SHA.
SHA is more secure, yeah. And then
Yes.
authentication is using pre-shared key. And then Diffie-Hellman group for integrity, which one I should use? 2 or 5 or which one?
Uh, let's use 5.
Okay.
The firma group, if you go more you go up, is more secure, right? Or no?
Yeah, more secure, more process consuming.
Okay. Yeah, let me use 5.
All right. And next step is crypto ISA KMP key. This is where we provide the password. Let's say Cisco123 as a password. This password should be same on the other side. And the address with whom you want to negotiate. It is 32.32.32.2. Right now, before this, we need to make sure we are able to ping this address. I'm not pinging because there is some problem with the routing. Maybe the interfaces are not up. I might have forgotten to say no shutdown. Let's verify. Show IP/OSPF interface brief. Here there is no problem between R1 and R3, but
Why?
what why? There is no problem, I said. There is no problem. The problem may be here in R3. Show IP interface brief. Uh-oh, I forgot to paste the configuration. Actually, I pasted for you to the email, but I did not paste it here. Now, let us check whether we are able to see neighbor. Okay, yeah, I see one neighbor. I'm expecting another neighbor. Show IP/OSPF neighbor. Show IP interface brief. Okay, I see one of the interfaces down. Interface G3/0 is down. Now I'm expecting again a neighbor, and the neighbor is, yes, it has come. So we got two neighbors, which means I'm okay. Which means I can ping now from R1 to R2. Let me try pinging again. This pings. Okay, this is the person with whom we are trying to negotiate VPN. All right. So what we have configured so far: do show history. These are the things I have configured so far for phase 1. So let me put this for you. For phase 2, what we need to do is we need to write the transform set. For that, the command is crypto IPsec transform set. And I'm going to give a name as tset to identify this transform set. And to transform my data or to encrypt my data, I'm going to use ESP, any protocol. I can use DAS or 3 days or AES, See, in phase one, I used AES. For phase two, you can use the same or you can use different. That's no problem. Let me use this, okay, for encrypting the data. Next, ESP MD5 HMAC for hashing. All right, now what is next is we need to have an access list to say which traffic should get encrypted. For that, I write access list and number, permit, all the traffic going in between 10.1.0.0, 0.0.255.255 to 10.2.0.0, 0.0.255.255. Do you understand this? Did you understand this access list? Any traffic, I'm not able to hear from you. Any traffic going from this subnet to this subnet, we want to encrypt. That's why I have written this access list. Next, after this, we need to have a crypto map. But before that, let me paste this for you to the notepad so that I will not forget.
Yes.
All right.
Yeah. The phases, and that's why I will go step by step. I repeat.
So the next is the crypto.
If I don't write it, I forget.
Okay. Now we need to apply all this to an interface, but applying to an interface is not possible. We need to apply it through crypto map. So I say crypto map. Give a name. I'll say CMAP. This is for IPsec. So give a number. And then this is for IPsec, ISEC, AMP. Match IP address or match address, the access list number, and then set transform set. The name of the transform set I gave is tset. Set peer. Who is the peer? For R1, who is the peer? 32.32.32.2. And then I need to go out to show history. Let me copy this for you. After that, second step is access list. Third step is you need to write a crypto map because you cannot apply this access list and transform set on the interface. You need to do it through the crypto map. So we have a crypto map, we call the access list, we have called the transform set, and we said who the peer is to negotiate. At last, we need to go under the interface, apply the crypto map to the interface.
So phase two is.
All this are phase two. All these are phase two.
Okay, the steps. What is the first step on phase two?
What?
What is the first step of phase two?
Transform set. Transform set.
Transform set.
Yeah. That second is access list. Third is crypto map where you call the transform set and the access list and the peer you call. At last, you need to apply this. This is the final step.
The five steps is the final one.
Yeah. Final step, what you do is you apply these things to the interface.
Because on the interview, they asked this how is configure IPsec, what is his steps, That's why
Okay.
I will number it,
Okay, fine. So what I'm going to do is I'm going to apply this to the interface now. The interface where I need to apply is G3/0. I'm going to apply. Before I apply, I want to enable Wireshark so that I can show you what all the conversations that go for IPsec. Okay, so as of now, only OSPF packets are going. I'm not interested in OSPF packet. Let's go and do the IPsec. So I'm on R1. I'm going to apply interface G3/0 crypto map. What is the crypto map name? CMap. That's all. Actually, we have finished everything on R1. We have finished configuring on R1. We need to do it on R2 now. But before that, I would like to paste this to your notepad for your reference. This is the step. Let me put it on your notepad. Right, so that's all on the left-hand side router. Now, same like this, we need to configure on R2. But before that, you see, I have enabled Wireshark. I'm expecting any conversation. There is no conversation so far. No problem. So next is we are going to go to the other side. Configure R2. I'm going to make use of the same notepad. I'll copy this. For R2, all these things are going to be same except this IP address. What will be the IP address? 13, 13, 13, 1. 13, 13, 13, 1. And this is going to be reversed, so this will go to the last. So any traffic going from 10.2, which is here, going to 10.1, coming from this going here, need to be encrypted. All right, now access list is also ready, transform set is also ready. Okay, here also you need to change the peer. It is 13, 13, 13, 1. That's all. I need to paste this on router 2. I'm pasting it on router 2. Good, there is no complaints. Now going to the Wireshark. Come on, where are you, Wireshark? Here it is. See, so far no ESP packets. Let me try to show you ESP. There is no ESP packet as of now. ESP is encapsulation security payload. As of now, there is no ESP. Right? Now, let us try to generate some traffic. I'm going to generate some traffic, but before that, I need to write a static route. I want to say IP route. In order to go to 10.2 network, you need to send the traffic via G3/0. Likewise on R2, IP route, in order to go to 10.1, you need to push the packet via G3/0. So when it tries to go out on 3/0, the crypto is configured there. And the crypto will start encrypting the data. All right. So let's see if any packet so far. No packet. Is there any ESP packet? No packet. Is there any ISA KMP packet? You see ISA KMP. ISA KMP is phase 1. There is no ISA KMP packet so far. All right. So let us now go to the command prompt and generate some traffic. Say I'm going to ping 10.2. What's the address we have? 10.2.0.1. I'm pinging 10.2.0.1 with the source 10.1.0.1. As I ping, wow, look at this, phase 1, phase 2, everything is done. And you are able to ping. You see that? You can ping and you're not responding, I don't know. Did you see that? Let me show you again. You see, this is phase 1. First, it was initiated from router 1. You see, Internet Security Association Key Management Protocol. Right? Now, this is called the main mode, exchange type, and it's a Security Association payload, and it's for IPsec. Let me pick the next one. Next one, when you see the payload, and it is ISA-KMP packet, right? And it uses UDP. ISA-KMP uses UDP 500. UDP 500. UDP 500. Actually, they're exchanging the key, but you will not be able to see. Look at this. It says for encryption, I'm using AES. For hashing, I'm using SHA. Do you remember this is what you gave? And the defilement group, you said 5. 5 means this is the size. The authentication method is pre-shared key. Right, and this is the pre-shared key. It's encrypted, so you cannot see. All right. So again, you can see key exchange happening. What is this? Come on, see this key? This is the value that is being exchanged, the exchange data. Actually, what is our password? What is the password we gave?
Cisco.
Cisco 123. But you see, you can't even imagine. It is no way showing anywhere Cisco. Fully hashed. And you see a lot of dots, which means some are missing. All right. So highly secure. Highly secure. See hash part of it. Now, and if you keep going like this, you will see a lot of key exchange between these routers and then from the main mode, this is where identity happens, and then they switch to quick mode. ISA-KMP quick mode. And this is the second ISA-KMP finish. All right, the verification is done. So it goes with the ARP request. Who is the 13, 13, 13, 1? And the ARP reply will come back. And the ping also started. Encapsulation security payload. You cannot see the data because it's totally encrypted. Now let me try to show you.
So the data is encrypted, yes.
Yeah, let me try to show you some pictures. Packet diagram. I'm showing you a diagram instead of the hash values.
Wireshark goes from you. Is so important.
Okay, now you see, this is layer 3, where you have the source IP address and destination IP address, and the top one is layer 2, the MAC addresses. And if you go down, you see ESP. This is where the encrypted payload is carried. But it won't show you all those things because it's encrypted. All right, so I just changed the layout and I showed you, but it's not that important for you. Let's put back to the normal view. Boom. Now, after that, wait, let me go to ESP filter. Okay, so all this ESP, this is what the ping packets actually that you are pinging. The ping packet. Let me try pinging again. You will see more ESP packets. Ping again. More ESP packets. See how many ESP packets? See here, there are 179 packets.
Where?
You see down here. Displayed.
Okay.
Displayed here. You see displayed. It is 8. You see 8 packets. Now let me try pinging again. Hey, come on. Ping again. You will see more packets. Ping, and now go back. Still 8 packets. Displayed ESP packets. How many are there? Only 8. Let me try to repeat pinging. Repeat for 100 times.
Yes.
I think I stopped the capture, that is why. Start the capture again. Okay.
I see, it's increased. It's 100.
No, it is increased because I removed the filter. Right, I'll show you again. Hey, those fun things are coming. Let me try again to sniff. Come on. Stop the capture and start once again. ISAC MPSA. It shows that it is active. The state, the VPN between router 2, which is the destination, and router 1, which is the source, the local, is up, active. Good. Right, so you need to now practice this, and let me know when you are done. We'll go to the new VPN concept.